Okay, now that we understand the mechanics of Cobalt Strike's infrastructure, let's talk about best practices. When you stand up multiple team servers, I recommend you have 3 tiers of servers. The first tier are what we call staging servers. A staging server is a server that hosts your client-side attacks and receives initial callbacks. These are also the servers you do your initial post-exploitation actions on, primarily privilege escalation, your initial lateral movement, and installing any persistence you want to install. You should expect that these servers will get caught very quickly, okay? The servers that you actually operate from and achieve your objectives from are post-exploitation servers. These are the servers where you do your post-exploitation and lateral movement. The servers that you should be very protective of are what we call long-haul servers. These are the servers to receive low and slow persistent callbacks that you've installed at strategic points in your target's network. You should only use long-haul servers to pass accesses to post-exploitation servers as needed. Now, let's talk about scaling red team operations. And scaling red team operations might mean multiple target networks over a long period of time, or one target network supporting multiple engagements over a long period of time. Either way, the model is the same. You want to have target cells for each target network or engagement. Target cell is responsible for objectives on a specific target or objectives for a specific engagement. The target cell's job is to gain access, conduct post-exploitation, and spread laterally. They also want to maintain local infrastructure for those tasks. And by local infrastructure, I mean their own staging servers, their own post-exploitation servers, and their own long-haul servers for their persistence, okay? As much as possible, target cells want to be self-sufficient for their engagement. But it's not realistic to assume that a target cell will operate without getting caught. To manage low and slow accesses across all of your targets over a long period of time, you want a global access management cell. The job of the global access management cell is to hold on to strategic accesses for all of your networks, okay, over a long period of time. This access management cell may try to gain its own access, but ideally it receives access from target cells. Now, the best access is the access that you actually never act from and never use. The access management cell should be there as a fallback or as a cell to seed a target cell when they need to perform some sort of objective, okay? So the job of the access management cell is to pass access to target cells as needed. The other thing the access management cell does is maintain global infrastructure for persistent callbacks. So these are the folks who stand up team servers, they stand up redirectors, they register or buy domains, and they take all the necessary steps to make sure you have good, healthy infrastructure for maintaining long-term access. Now, let's talk about team roles. No big surprise, the team roles are very similar to how I stratify the different types of Cobalt Strike infrastructure. On your team, you want members of your team devoted to access. Their job is to get in, potentially through targeted spearphishing attacks, or, if your rules of engagement allow it, very controlled, very careful waterholing attacks. The access team is also responsible for trying to expand your foothold, okay, and spread laterally into a network to key places. The post-exploitation members of your team are responsible for searching for information. They're responsible for user exploitation. These are the folks that will ultimately take action on whatever objectives you as the red team have. On your team, you also want a local access manager. My friends and I refer to access managers as Shell Sherpas. We call them Shell Sherpas because their job is to herd and protect the shells. Access managers manage callbacks, okay? So any callbacks coming in to your long-term infrastructure are managed by the access manager. They also set up infrastructure for your teammates to use. The access manager should also be the person designing your persistence scheme. Persistence is an art. It requires very careful testing. You don't want each of your teammates trying to become experts in how to do this. It's better to let a specialized cell in your team craft something, build a script, and give it to your other teammates to use. Now that you know about some of Cobalt Strike's best practices for distributed operations and team roles, let's talk about something else that's also very important, and that's logging and reporting. Cobalt Strike logs everything on the team server. All of the logs are stored in the logs folder in the same directory where you started the team server from, okay? And here's a snapshot of some of those log files. These files are logs for individual beacon sessions. They're organized by date, in this case September 11th, 2015, and target, and individual beacon session. The number in the log file name is the beacon session ID. Keystrokes and screenshots are saved as well, and they're organized by date and host also. The screenshot's name is screen_time. So in this case, it's 1:53 and 21 seconds, so almost 2 a.m. And then session ID is the last number. Something else important to note. Cobalt Strike session log files give you attribution for each task. So the input block is the command that was run and the operator that issued the command, along with a date and timestamp. The Cobalt Strike logs also give you Cobalt Strike's narrative understanding of the task that was issued to it. Cobalt Strike also takes steps to log indicators that a blue team may be able to observe in the log files as well. So here we have the MD5 hash of a file put on a target. You can see the check-in times for each of the beacon sessions and the output that was provided by each beacon as well.